Hi, my name is Ivan, and today I'll be talking about style guides and, in particular, about how style guides can support the rapid growth of your engineering organization without sacrificing technical excellence. But before I start, just a few words about myself and about Tide. So, actually, my combination of names is pretty unique. I'm I live in Bulgaria. I'm based in Bulgaria, but my father is Polish. That's why my surname isn't typically Bulgarian. So yeah, I'm really easy to find on LinkedIn and elsewhere. Just if you're interested, search for my names, and I'll be probably the only result. So I've been working at Tide since 2020, and Tide is actually building a business financial platform that's focused on helping small and medium-sized businesses, and we're actually helping our members. That's what we call the businesses that are our customers. We call them members, and we are helping our members to save time and money by automating things that might otherwise be hard for them, and handling various interactions with government institutions or other third parties that would be otherwise slow and unpleasant. And during my time at Tide, I've seen how our engineering organization has almost tripled in size, and I've been able to see firsthand what policies actually enable such rapid growth without sacrificing technical excellence and while maintaining the overall quality of our software delivery. And before joining Tide, I've spent around 8 years in the gambling industry, and in general, I'm interested in things like microservices, event-driven architectures, and obviously policies that enable or software organizations to grow and scale. Basically, the things that I'll be talking about today. So let's get straight on to the topic. So, why does your organization need style guides? Uh, First, let's look at what a style guide actually is. At some companies, these are also called guidelines or standards. At Tide, we are actually calling them guidelines. So I'll be using both terms today because for me they are just synonyms. They mean the same things. So, style guides are actually collections of best practices, rules, conventions, processes, and things like that that are applicable to a specific subject. So, unlike broader things like architectural principles or just overall understanding of what good software engineering looks like, guidelines shouldn't be general or applicable to a broad class of problems. They should be focused on particular subject, and we'll have a look at some examples of topics for guidelines in a minute. And the, probably the main thing that I would like to convey today about style guides is that they promote consistency and knowledge sharing, and they reduce the dependency on tribal knowledge. And I'll explain later on why that's the case. So, since I mentioned tribal knowledge, let's have a look at why tribal knowledge can't scale well. And yeah, it usually might work fine in a smaller organization, in a small startup that just starting, that you have just 3 or 4 people and you're trying to survive. But as the organization grows, tribal knowledge turns out to be problematic. So usually, the few people holding the tribal knowledge will need to handle more and more requests for help when the organization grows. And at some point, these people will start spending almost all of their time on blocking others. And as the organization continues to grow, their time just might not be enough. They might start spending so much time that they spend their entire day doing this, and they might not even be able to help everyone that needs their help. And more importantly, these people, they won't be at your organization forever. They'll just start looking for new challenges at some point, they will leave, and then this tribal knowledge will simply get lost. So you obviously need something else in order to ensure that this knowledge about best practices and what just good looks like in terms of software and engineering at your organization. So you need to make sure that this knowledge is somehow documented so everyone can access it, even new joiners. So here come style guides, obviously. And some now let's have a look at some topics that could be examples of style guides. For example, you can have a language specific guideline like a Java coding conventions or a Python style guide. Or you can have a guideline for designing RESTful APIs, or a guideline for asynchronous messaging, or a guideline for using databases, or a guideline for performing code reviews, or even a guideline for creating other guidelines. At Tide, we have such a guideline and basically describes what a proper guideline should look like and what sections it should contain and so on. And here is just a brief example. Um, that's just a screenshot from our REST API guideline. And this is probably our biggest guideline. It's really extensive, and this is just one of the rules we have there. Um, this is just a very simple rule about what the request bodies should look like. And as you can see, it basically states that each request body should have at least a data object inside it. And that's basically it. And let's discuss in general what are the things that are worth creating a style guide for. So, in general, a good advice is to just observe the issues that arise frequently in your organization. So, what are the things that your software engineers usually struggle with? Things that they often have the same questions, they hit the same roadblocks, or they just get stuck on um, with something, or they just struggle with implementing something properly. So if you observe something like that that just repeating quite often, then it's probably good to create a style guide for this particular subject. Another really important thing is observing things that people are doing in different ways with no good reason for it. Let's take again designing REST APIs as an example. So if you notice that different teams or even different engineers are using a different format and structure for their REST API requests and responses, then it's probably a good thing to create a guideline for this, because otherwise you'll end up with really inconsistent REST APIs across your services and across your system. And for example, if you notice that different teams are using a different library for the same purpose, like accessing a database, again with no good reason, where there isn't a situation where just a particular team needs a specific feature that's available only in a certain library, but they're just using a different library than everyone else just based on personal preferences. It means that you probably need some guideline about using databases, so people start doing things in the same way. And but of course, having too many guidelines can actually be counterproductive, because keep in mind that each engineer needs to be familiar with the guidelines that your organization has. And when they're implementing something, when they're creating some feature, they need to make sure that they conform to these guidelines. So make sure that you create guidelines for things that really matter, that are important for you, and not for things that most of the people are anyway familiar with. And also keep in mind that each new joiner at your organization needs to get familiar with all your guidelines. And basically, reading the guidelines is probably one of the first things that an engineer does when joining an organization. So if someone has spent like 5 days just reading all the guidelines, it first it will be kind of boring, tiring, and probably it will just be overwhelming, and that person won't be able to remember everything. So yes, a large set of guidelines can be also counterproductive for the onboarding process of new engineers. And now let's see how we can divide the types of rules that can become a part of a guideline. So we can usually divide these rules into three groups. First are the rules that prevent disasters. For example, we can put here rules that relate to security. Let's say rules about securing your REST API endpoints. And obviously, if your APIs aren't properly secured, this can lead to all kinds of issues. Um, your users' accounts might get stolen, their data might get leaked, and if you're working in the financial industry, for example, your users might lose money and so on. So basically, something the results might indeed be disasters for your company. That's why we're putting these rules in the first place. And second, we have rules that enforce best practices, like, for example, rules that make sure that your code base remains maintainable as time goes by. And these type of rules, they enforce the non-functional requirements for your system, or the so-called utilities like maintainability, reliability, and so on. Obviously, if your code base is not maintainable, your company won't fail immediately, at least not in the short term. Obviously, in the long run, with an unmaintainable code base, your organization will most likely suffer. So yeah, these rules might not be as important as the first group, but they are still really important, because making sure that everyone in the organization has a common understanding of the best practices is indeed something that needs to be there. And third, but I would say not least, is are actually the rules for consistency. And while they might at the first glance relate to things that might not be so important, like format and naming conventions, and things like the example that we saw before, related to the structure of your REST API requests or responses. These rules are especially important in larger organizations, and we'll see why that's the case on the next slide. Because consistency really brings big benefits in bigger organizations. Um, First, consistency enables internal open source. And what's internal open source? Imagine having an organization where you have a microservice architecture, you have hundreds of microservices, and each team owns several microservices. So usually teams could communicate with other teams either using REST APIs or some event-driven mechanism. And sometimes when you need to investigate an issue or just integrate with another service owned by a different team, there might be some problems, and you might need to have a look at their code. And if their project structure is the same, if they're using the same libraries as you do, if they're following the same format and naming conventions as you do, an engineer from your team will be able to really quickly go to their service, open their code, and understand what's going on, because everything will look really familiar to them. The only difference will be just the business logic. And even if you need to do a quick bug fix because something's not working and you need to get unblocked, you won't be depending on that other team to do this for you. Since everything is almost the same, you can do this bug fix on your own without having a dependency on that other team that might be really short-handed at the moment, that might be busy with something that's even more urgent. And having internal open source makes easier transferring service ownership. For example, if a team um, just loses an engineer and or for some other reason is not able to own a service anymore, that service might need to be transferred to another team. And when you have that consistency of structure, libraries, format, naming conventions, and so on, it's much easier to transfer service ownership. But when it comes to consistency, there is this trade-off between consistency and freedom. So consistency doesn't come without a price. So um, usually different people have different preferences in terms of libraries or tools that they prefer to use, or even in terms of minor things like format and naming conventions. So when you try to enforce consistency, you're actually limiting the freedom of your engineers. So you're actually saying for accessing databases, you need to use that library. For serializing or deserializing JSON, you need to use that library. And obviously, some people might prefer a different library, but the truth is that in the long run, in bigger organizations, consistency will always win over unrestricted freedom by a large margin, because even if someone has a certain personal preference, allowing them to use something that they prefer um, would mean that when that person leaves, someone else would have to maintain this, and that other person might be more familiar with another library and so on. And if you allow unrestricted freedom, it would mean that at the end you end up with a really inconsistent code base. And another thing about consistency, that it actually saves time, because people like discussing various things, even things that might not be so important. Like, for example, discussing whether to use snake case or camel case for the query parameters in your REST APIs. So this doesn't seem that important, but again, some people just have their personal preferences. But when you have style guides and when you have these rules for consistency there, these discussions are simply eliminated, because people just have to follow what the guideline says, and there is just no place for these discussions. Obviously, I'm not saying that discussions are something bad. They are really important for a healthy engineering culture. But by eliminating these unproductive discussions about really minor things, we are actually saving time for discussing things that really matter, like high level issues like architecture and so on. And now let's see why automating your style guides really matters. First, it again spares your engineers from having to check for boring things. Imagine that your engineers need to check um, if the request bodies or response bodies of your REST endpoints conform to the REST guideline. And depending on your REST guideline, these request and response bodies, they might be quite complex. And checking for this in each PR is obviously boring. And people are not machines. They make mistakes. They might not catch all the cases where a certain REST endpoint is not conforming to a guideline. And checking for such things like format and naming conventions is one of the cases where machines can perform much better than humans. um, because machines don't get tired, they don't make mistakes, and more importantly, they are much faster than humans. So an automated tool that can analyze your code can probably analyze thousands of lines of code in just a few seconds, while a human engineer will need probably several hours to do this, and they'll probably miss a lot of the cases that are violating some guideline. And this leads to a next conclusion, that guideline automation actually helps you scale, because it's much faster. It saves time. Your engineers can focus on other things. Um, During PRs, they can check if the code in the PR actually does what it states it's doing, instead of just checking about guideline rules and so on. So guideline automation is something really important when it comes to larger organizations, is especially if you have a large set of guidelines. And when it comes to guideline automation, it's also it's another benefit of having consistency across your code base, because if you have various exceptions to the rules in the different services that you have, it means that you'll need to handle these exceptions in the automated tools that you use, or that you create on your own. Because for some of your guidelines, you can probably automate them by tools that you can just buy, or use some open source tools. But for some of your guidelines, you might need to write your own tools. And if your code base is consistent and it already follows the rules, then it's much easier to create these tools. And finally, my last slide would be about managing style guides. So in general, anyone should be able to propose a new style guide. But whether it gets adopted depends on the entire engineering community. Of course, achieving 100% consensus is not something realistic, because you'll always have people that won't agree with something. But if you achieve a simple majority, it should usually be enough to adopt a guideline. And usually, it's a really good advice to designate a group of experts as owners or gatekeepers of each guideline. Um, because at some point, people will get unhappy with some of the rules in the guideline, or someone will prefer one change, or another person will prefer a different change, and so on. And you'll need a group of experts on that particular subject that relates to the guideline, who can have the power to approve or reject changes to that guideline. So every change should go for that group of experts, of course, while consulting with the wider community. But especially critical guidelines, like the ones for security, or even your REST API guidelines, um, they should be managed by a really tight group of experts, and changes should be restricted. But of course, style guides shouldn't be set in stone. You should observe how your style guides actually affect your engineers' work, because it might turn out that some of the rules are counterproductive, that they are causing more issues than they solve. And as time goes by, new versions of the relevant languages are released, or new versions of the libraries that you use are released. And some of the rules that you have might might just be related to older versions of these languages or libraries. So you'll obviously need to change your guidelines at some point. You might even need to deprecate a guideline and propose a new version of a guideline. But a really good piece of advice is to always be data driven with decisions about your guidelines. Just so try collecting some data, even if it's just creating some surveys and seeing how engineers react to a certain guideline or a certain rule in a guideline. So if it turns out that a certain rule is actually slowing down your engineers, and the benefit it brings um, is less compared to the negative effect that it has, then it might be a good advice to just change the guideline. And yeah, that was all from me. So looking forward to any questions or any comments related to my presentation around style guides.